When you shop online, the credit card number you input has to be accurate, otherwise you cannot complete your order. That's an example of error proofing or mistake proofing. In Lean, it is often called poki-yoke, from the Japanese terms poka, meaning mistake, and yokeru, meaning to avoid inadvertent error or human error. Wouldn't it be useful to error-proof or mistake-proof your processes, products, and services? Let's discuss the basic principles of error-proofing and how they can be applied. Error-proofing is best when it prevents error from occurring. If that's not possible, the next best thing is to facilitate the work so that errors are minimized. Lastly, if errors do take place, then detection should be made obvious and immediate, or be automated. There are basically 3 levels of error proofing. Here they are in order of preference. 1. Prevention. 2. Facilitation. 3. Detection. The first and most preferred is error proofing by prevention. An example is the traction control system in cars. It works actively, full-time, to prevent wheels from overspinning on slippery roads or low-friction surfaces, regardless of how good or bad the weather is, or the driver is. Prevention-based error proofing is also possible in processes. For example, in-store pickup of a prepaid online order. In addition to showing a driver's license, the same credit card must be scanned for the system to authorize and process the pickup. If prevention is not possible, then the next choice is error proofing by facilitation. An example of this is anti-lock brakes, in which the car helps facilitate your application of brakes in an emergency, so it is done efficiently, effectively, and the brakes don't lock up. Similarly, in processing transactions, dedicated pre-programmed buttons, such as those on point-of-sale systems for cheeseburger or large fries, are used. Also, you can connect your point-of-sale system to inventory management. It can help you track inventory and prompt you when and how much to order. Or, as I've experienced recently, many easy-to-assemble furniture are not easy to assemble. However, I've come across some well-designed, truly easy-to-assemble furniture where parts to be assembled to each other are labeled by the same matching numbers, and the parts fit perfectly. Facilitation-based error proofing makes it easier and it minimizes errors, but it does not prevent non-compliance due to forgetfulness or human error, such as pressing the wrong button by mistake. If prevention or facilitation is not possible, then employ the third choice, error proofing by detection, where detection of errors is immediate, either by being made obvious or by automated detection. An example is the annoying beeping sound and warning light in your car to alert you when you forget to put on your seatbelts. Another example is the fuel gauge, when the warning light comes on when the gas tank is low with a range of less than 30 miles left. The only trouble is, for me, when I finally notice the light, I'm never quite sure if it just came on or if it came on 25 miles ago. To summarize, if prevention is not possible, use a combination of facilitation and detection. An example is a combination of anti-lock brakes, seat belts, and airbags. So, prevent errors if possible. If not, minimize errors, or at the very least, detect and mitigate its effects immediately.